The Human Torch was denied a bank loan.
I haven't heard that one.
Really?
I haven't heard that vocal exercise, yeah.
Quote from Anchorman.
Oh, that's
yeah.
right, yes.
Yeah.
This burrito is delicious, but it is filling.
Welcome to the Cables to Clouds podcast, your one-stop shop for all things hybrid and multi-cloud networking. Now, here are your hosts, Tim, Chris, and Alex.
Hello, and welcome back to another episode of the Cables to Clouds podcast. My name is Chris Miles at BGP Main on Blue Sky. I actually went and changed the domain, Tim, so you'll be happy.
Excellent.
Kept it consistent everywhere. And yes, as you heard, as always, I'm joined by my good friend Tim McConaughey, my co-host, my partner in crime, my heterosexual life mate, whatever we want to call each other. But yeah, we have a special one today. So this is a post-holiday recording. We're all fat, dumb, and happy from Christmas. We filled our guts, and now we want to chat about some cloud observability stuff. So we've brought on a good pal of ours, Craig Johnson from Forward Networks. So if you've been involved in any of the podcast and technical media circuit, you've probably seen Craig out there. I think you've been on A1 as well as the
yes.
Cloud Gambit, right?
Mm-hmm.
So yeah, he's making his rounds.
Yeah,
You know it.
But no, we had a good chat at AWS reInvent this year, and we thought it'd be a good chance to come on here and talk about some of the stuff that's happening at Forward and the concept of digital twins and how that applies to cloud network observability. So with that, Craig, tell us a little bit about who you are and what you do.
Yeah, thanks for having me. So, yeah, my name's Craig Johnson, live down here in the great nation of Texas. So I've been at Forward for a little over 5 years. So I'm a technical solution architect. I also lead our public cloud practice. But really, I didn't start out in cloud. So I really only moved to the public cloud probably about 3 years ago. On my back left corner, you'll see my multiple expired CCIE. So most of my time before that was completely on-prem, working with service providers. I spent a decade or so at Cisco, worked on the operations side. But most of that was either in the data center, or, storage area networking or campus networking space. But yeah, for the past five and a half years at Forward, been focused on network modeling, digital twin, and for the last 3 or so has been purely based on cloud modeling.
Nice. I will say, at least you've got one of the old school CCIE plaques. That is, in Tim and my day, I feel like the plaque we got, I call it the ugly baby because it's a hideous thing that I don't want to hang on my wall because I hate the way it looks.
Yeah, you see, I don't have mine behind me. I didn't have space for it after I put all the posters up. So
it definitely degraded over the years. I've got the old metal one from 2001, and then they started doing just kind of a simple one. And then by the 2010s, it was like, come on, Cisco. It's like when I was there and they took sodas away. It's the same thing,
I'm going to completely derail this for a second. I just noticed that you have the red dragon. I also have. I have that exact same red dragon.
Nice.
I noticed it. I was looking at my bookshelf, like, holy shit, we have the same. We both have the red dragon.
I had no idea. Yes, there is a plethora of I just redecorated this room, so the color and the flooring is all new. So I have that. Below the red dragon over there is several D&D 3rd edition books that I still have. They're not particularly useful anymore, but yeah, absolutely.
Yeah, good stuff, man.
Awesome. Well, yeah, Craig, thanks for that. Thanks for coming on to the show, obviously. And so let's start with I guess kind of an overview of the problem, right? When we had the idea for the show, we wanted to talk about what the problem was, and then we can kind of venture into how to solve that. So, network monitoring and network observability has been a thing in the on-premises world for a very long time, and I'm curious to get your take. How has that made its way into cloud? Because cloud seems like it's this new paradigm where there's integrated APIs everywhere. You should be able to get as much visibility and observability that you need. But that doesn't seem to be the case in day-to-day operations. So from your perspective, like what is broken about cloud networking monitoring and observability?
So what I'll say is particularly broken, in my opinion, is one from the very obvious. In contrast to on-prem networking, where, if I want to swap out a Cisco, router for a Juniper router for an Extreme one, they all basically do the same thing. And, they're going to have ribs, they're going to have fibs, they're going to have forwarding tables, input and output ports. And when you go inside the, it's going to do something with the packet. So it's a very easy kind of swap out. That is, as you know, not the case at all if I want to switch from AWS, Azure, GCP, or OCI. Obviously, there's something underneath all of those that do those, but those are completely opaque to us. And the visibility that I get within those are very, very much limited for administrative control reasons and just by nature of it. Like if I want to have any level of visibility in AWS, I'm limited by, of course, which account I'm in and which region I'm in, because they made that decision to, separate the control planes. Azure's a little bit different, but I'm separated by tenants and subscriptions, similarly with GCP and projects. So the scope of what I can actually see is quite limited, and the actual way that the forwarding function is very, very different. As you probably know, the way I forward in AWS is drastically different in the level of tools that I have versus Azure versus GCP. So it's much, much more difficult, and with many analysts saying, oh, you should go to multi-cloud, or you should have, many different accounts for separation. That sounds nice, but the challenge of actually being able to, one, figure out where my packets are going, if they are, moving correctly, and if they're taking the best path is extremely difficult. And I've not seen any other tools out there. There's a lot of other tools that will tell you, give you some visibility into your instances, into your databases. Very few that I've seen will actually do it on any sort of network and transport layer.
Yeah, definitely. It's interesting what you mentioned about the how like AWS separates control planes and also visibility essentially through between accounts, because a lot of people are like, oh yeah, like observability is tough, but you have CloudWatch and they give you all these tools, but then they split them all out from each other, right, even within the same cloud, and it becomes a Herculean effort to try to stitch it all together across the different accounts, and whatnot as well.
Yeah, and it's just a very different paradigm from how we do things on. I should hit myself using that word. Than how we do things on-prem, because I don't care how many applications, clients, and tenants I have. It's all going through the same set of infrastructure when I'm dealing with anything on-prem. The separation just makes it extremely difficult for me to figure out anything in there. And one, even just dealing with, people that really may not be as familiar with how the forwarding works. And that it does just change quite a bit more often than I would like to see versus on-prem. When I started, 25 years or so ago, speeds and feeds have changed, but forwarding is roughly the same. And, if I would do AWS 5 years ago, I'd be woefully out of date and things wouldn't work anywhere the same way.
Yeah, to your point about, the way forwarding works differently between the clouds, like the monitoring piece is all different as well, right? So it's like in AWS, you have to, potentially come up, you're a network engineer, but you have to come up with this complicated Athena query in order to actually, come up with what your traffic's doing on a day-to-day basis. But that doesn't really apply to Azure, GCP, any other clouds you could be in.
It doesn't apply, and I don't get anywhere near the same tools. And I will applaud the cloud providers for starting to get a little better on this, but it's not like I can go log into a transit gateway and do a trace route to figure out where my path is going. And hopefully I don't have things that are blocking my standard ICMP tools, which is where you do get other data plane observability tools, which is great for figuring out latency and if things are working or not, but it doesn't actually tell you if something isn't working where the problem happens to be.
Well, and if you do something like, say, VPC Reachability Analyzer, God forbid you have any non-AWS architecture anywhere in the way, you're done, right? Like that's it. You're not going to use that tool at all.
Yeah, that's of course the pitch. It's like, oh, you want to use something else besides AWS Network Firewall? Oh, sorry, you're out of luck.
It's kind of like the Apple approach. I feel like when you're fully in the ecosystem, like things work and thing looks all hunky dory. But the second you want to venture outside of that, it's like, well, they're shrugging their shoulders, like, well, you could buy our shit, and then we know this will work. But majority of network people in the cloud are using some type of third-party firewall for integration and stuff like that, and that visibility is completely lost.
Exactly right. Yeah. Like you can see, oh, I'm hitting this ENI interface here to my traffic, and cross my fingers that whatever that thing is doing is doing it correctly.
Yeah, I mean, people open tickets all the time for the forwarding problems. Chris is killing something over there. But all sorts of forwarding tickets where you have to get support involved because they're literally the only ones that can actually see what are happening to any of the packets, right? Your VPC flow logs might say everything's great, but there's still a problem, and you go to find out that this availability zone is having an outage at this time, and so the tools they give you are opaque, but also not. I don't know. I don't feel like they're truly real time, or like they don't dig far enough to really give you the visibility you need.
Yeah, I think that's exactly right. I'm reminded when I used to work in operations, the answer to those sorts of problems in a data center or in a campus was, let's get the sniffer out and let's see that. And it's the same sort of issues. You can look at flow logs, you can try to generate packets, and it's sort of going to tell you something might be, but it's not going to tell you if you're taking a good path, or if I'm hitting any. It might tell me that it's working or not working, but yeah, it's only going to be working if that traffic is actually working at this time. As an engineer, when I'm troubleshooting, I don't always have the application running at the time that I'm doing it, or I'm trying to pre-do it before the application's even on board. And that's really the problem statement that we set out to try to solve, is to be able to not just observe what's going on the network in the cloud right now, but to model all possible flows and anything as it might be traversing the environment.
Yeah, gotcha. And one more thing that is in the cloud that we haven't thought about, or not that we haven't thought about, but that we didn't have to really think about that much on-prem, but we absolutely have to think about in the cloud, is the cost of troubleshooting. Like the visualization, the observability costs of doing VPC flow logs, a reachability analyzer, of all of the port mirroring, right? Port mirroring is all of these things require. And those all have costs associated with them, and you're doing it in every cloud that you exist in, right? Like if you're doing troubleshooting in AWS, you're probably also doing it in Azure if you're there as well. So you're paying for that as well. You're double, triple paying for a lot of these tools, and it's something you never would have thought of on-prem, right? On-prem, you stroke a check to, I don't know, SolarWinds or whatever the hell tool that you're using, and then you just keep it once a year. You're paying the fee and you're good, right? But here it's consumption based, so every time you have a problem, you're essentially paying money to solve your own problems.
That's exactly right. Like I remember, before I was at Forward, I worked for a network packet broker company, and that was the line as well. Put taps and spans on every place in your network, and as you're probably aware, that's completely infeasible. And it's exactly the same thing on the cloud, because it's just, one, it's far too expensive, and two, it's just far too much data to do anything with. I mean, I can't, even if I tap, if I want to look at all north, south, and all east, west traffic, that's a massive amount of data, and it's just too much to actually be actionable in any way.
Well, it's funny too, because with the introduction of cloud, it was kind of this whole, one of the big selling pieces was like, hey, you get to start from scratch pretty much. You get to build an ideal architecture that's built for the cloud. It's built in this, but it's never ever that way because of cost. We've inherited that problem tenfold in the cloud, just as much as on-prem. Whereas we've had to put things in these centralized type architectures, and then if it's a multi-cloud flow, then you're doing it centralized in two different ways. You're paying for the storage, you're paying for the monitoring on everything. It just it's exacerbated like crazy.
Yeah, you're precisely right. Like to the account example, I've seen people get started with simple architectures and a handful of VPCs to some customers I work with that have literally 800 accounts and a different transit gateway per account, and they're all paired to each other and shared, and it's like this is a nightmare. Yeah.
That sounds truly awful.
Yeah, and AWS's solution is to your point, just use Cloud WAN or just use VPC Lattice or something like that. But you're kind of just masking the complexity, which, to be fair, we've done the exact same thing on-prem. If I have too much complexity in my environment, put an overlay on top of it. I get it.
Make a fabric.
Yeah.
100%. So that's obviously we've talked about this for about 10, 15 minutes at this point. So we know there's a problem, right?
Yep.
There's something to solve. So let's kind of pivot here to talk a little bit about forward networks and
Sure.
and how you guys are addressing this and solving some of these problems.
So to the example I said before, where if you look at all of your devices on-prem, no matter what the vendor happens to be, they all basically do the same thing, whether it's a switch, router, firewall, load balancer. A packet comes into a particular input port. That device does something with the packet, does a header rewrite, does a macro, adds a header on top of it, whatever it happens to be, sends it out to an output port, and that's all the device does, no matter what, so it processes through a number of tables and goes through them. So when we started at Forward, we all came from, your Cisco's and places like that. So we're very familiar with that problem. As we started moving along, obviously, we don't want to have holes in the way we model the network, because once you take all of that data, you want it to be easily searchable and normalized, because you don't have to be, a pure expert. I'm pretty good at most Cisco devices, but, Junipers and Palos and Fortinets, I would really struggle on that. So being able to understand the forwarding characteristics, and the key to that is not necessarily tell me what's the actual traffic that's going through that device, but tell me, what's if I'm looking for a particular source destination IP with some port characteristics, tell me how it's going to pass through all those devices based on the current rib, fib, everything, all the tables on that device. The innovation that we had is essentially the public clouds work the exact same way. Now, they all have their own little quirks to them. But when I go, like if I'm leaving my data center and I'm going off of, an express route or direct connect, that's going to connect to a VGW or a TGW or a VNet gateway. Once I hit that TGW, it has essentially the same things. It's going to have it's going to have VIFs that go in and out of it. It's going to have peering connections and associations. It's going to have a number of route tables, which function very much like VRFs. As you pass through each of those constructs, you go through a TGW that's going to connect to a VPC somewhere, or that VPC more specifically is going to connect to a route table. That's going to have connections into a subnet, and then that's going to have EC2 ENIs attached to it. And we saw that, okay, well, we already have the concept of doing this on-prem. It's very easy for us to extend that. And at the same time, we can take everything that we have, because I can say, well, I don't just need to collect from one account. I can collect from multiple accounts using just a simple IAM role. I can do it across multiple regions. The key insight that we had, to your point earlier, is, well, wait, if I do have something like a Palo or a Fortinet or whatever firewall inside my cloud, that's just, a collection of a couple of ENI, maybe IPsec tunnels, whatever they happen to be. As the traffic hits that ENI, I can process that firewall just like it was a device on-prem. So then I can see my end-to-end connectivity just by putting in that source destination IP address. It's going to tell me how it passes through each one of those constructs. That was really the key innovation. And that's really where I got my start, is when I started doing any sort of cloud thing, probably around 2020, 2021. I didn't really know very much at all, but using the ability to collect from these, like, okay, well, when I want to configure anything on AWS, if I want to set up a file, how's exactly it's forwarding? Oh, did I configure this route table correctly? Did I configure this ping? Did I configure the security group? There's 100 different places to check inside the cloud for any number of things. Being able to step through it step by step, and to the point earlier, not have to log into a bunch of different accounts, a bunch of different regions, made it a very, very key insight that we were able to use.
So no, that's great. So what I'm hearing is basically with Forward, now Forward got started on-prem, but this is now an add-on basically. Now you've expanded into cloud. Mm-hmm. The idea is that you can onboard your accounts to Forward to Forward's. I guess it's a platform, right? It's appliance, yeah. Or mm-hmm. Yeah, okay. Yeah. And then basically because of that, Forward can go reach out to all of your accounts in whatever clouds. Also, I assume there's also going to be like login information or whatnot to hit firewall, any third-party ISVs like firewalls, yeah. Cisco, whatever.
Yeah, API, CLI, whatever it happens to be.
However you can access it, right? And that's going to help pull all that in. And because you get all that data, and because the options are limited, in which case how traffic can be forwarded, how it's mm-hmm. going to work. You can just model that right? You can just model. It doesn't actually send the traffic, but you can model the entire path because you know everything the packet's going to do, basically.
Yeah, and that's really the cool part is when you start looking into this level of modeling, it's not anything you couldn't do yourself. Like when I log into a router, I can look at the fib, I can look at the route table, I can look at all the ACL tables, I can look at all the CAM tables, I can look at any MPLS forwarding that any labels that are getting pushed and popped. These are all things that you could do and probably have done many times in your career. Not really that much different on the cloud. I'm using EC2 APIs to grab the transit gateways, transit gateway attachments, transit gateway route tables. Now, the cool thing about this is this doesn't have a cost. This is completely free to grab any of that from AWS. There's no observability cost. There's just the same APIs that when you log in the console, you're seeing the exact same thing. We're just grabbing it from an API basis to show you that. So it makes it be something that you have right there. And it's also something you can track over time, which is one thing I really like because, yes, to your point, you could look at CloudTrail logs and see what's changed. You could look at CloudWatch and see if something is not working. But trying to go back in time to say, hey, what was the state of the forwarding information in the cloud 2 days ago, a week ago between changes? That's really, really not easy to do, and not easy to do in a way that makes sense to a network engineer. Like I can grab API output from different points in time, but it's a lot of data to parse through and not in a way that makes a lot of sense for a network engineer.
So it sounds like there's kind of, I mean, the way I'm thinking about it, there's kind of two pieces here. There's either the predictive analysis where you're judging based on the existing control plane at a certain snapshot in time.
Right.
If a packet were to go through this network, how is it going to get from A to B? You can predict that. Is there a bit of a postpartum type analysis piece to this as well, where you are looking at flow logs and you say like, okay, actually this packet did come in and you follow the trajectory in an kind of a, like I said, a postmortem analysis manner versus a predictive manner? Is that possible?
So the postmortem side is absolutely doing kind of diffs between before and after things and saying, okay, between 2 points in time, here is not just what changed from a routing, security basis, but also on an intent basis. So all those things, if I have a particular application or a flow that says, hey, this application, exists in my data center A, and it goes, hops between region B, and maybe it goes to a different cloud, whatever. That's an important application that we have imported from those kind of flow logs. And then every time that, a digital twin like Forward takes a snapshot of the environment, it's always checking those, dozens or hundreds of things to say, hey, is this changed? Is it always taking the shortest path? Are there loops in the network? Is there anything that would stop the connection between all of those? And because it's analyzing everything along the path, layer 2, layer 3, overlays, firewalls, MPLS forwarding, all the way up to the cloud, it's going to tell you if it's changed, and two, if you've done something to break the connectivity, so you can see that postmortem level, like, hey, this particular flow doesn't work anymore, and it's because somebody changed a security group or somebody, it's just unassociated something from the transit gate or whatever it happens to be.
So how, I guess, the big problem with cloud observability we were talking about, of course, is the cost of doing that analysis, which Forward takes care of because, it's just predictive modeling. But also the storage, like how much data, I mean, it sounds like you have a pretty, because you're doing diffs, right, of some kind. So, I mean, what does that data storage model look like? Or how are you storing the data or doing what the data?
So there's two pieces of data you're dealing with. One is kind of the collected data, which tends to be API data from anyone. Now, this is metadata. So we're not talking about going into an instance and grabbing all of the data about all of the instance storage or anything like that. This is going to be metadata on, in my VPCs, these are the entries for all my route tables. These are the associations for all the subnets. These are all the ENIs that are attached to the subnets. So in a large account, it can be, dozens or hundreds of megabytes, but we're not talking gigabytes and terabytes of data that you're grabbing. Now, on the back end, once that data is gathered, then there's kind of derived data, or the IP is what they call a mathematical model. It crunches all of that, figures out all of the literally quadrillions of possible flows between all of the places. And that's really kind of the key to what Forward does a little differently, is because there are other things out there, like you've got local stack out there that tries to emulate some AWS things, and you've got things on-prem that try to emulate what actual devices would be, you run into that kind of hard limit when you want to, emulate a large environment. So that's where modeling really comes in, is because we're modeling, you can, scale up to, 50, 60, 70, 80,000 devices and, many, many, many hundreds of accounts without an issue, because all of that data is derived and is just based on mathematical crunching. It's not based on each individual device and looking at all those quirks, because it's all normalized out.
Right. Yeah. So on this, you did mention digital twin a moment there, and the concept of modeling. So should we kind of maybe define exactly what digital twin means to Forward in this context? And I'm assuming this is something that originated in the on-prem product and now has moved into the cloud, right?
Yeah, it's a term you'll see a lot, and people use it in a lot of different ways. The way we sort of define it is a way to, what we said before, to essentially take the exact forwarding characteristics of any device that you have and essentially turn it into a common model. So if you're familiar with what OpenConfig used to be, which is still around, of course, there's already this concept of, all of the devices have a sort of common model. Now, some devices are better than, some vendors are better than others about, conforming to that model. And of course, the cloud providers aren't very. So we've taken that and extended this a little bit to say, what's common across all of these, and by turning it into this OpenConfig plus extensions kind of common model, then we can use that to figure out the forwarding characteristics. And then you can simply query that digital twin to do what I said before. Tell me this source IP, this destination IP with these ports of protocols, app IDs, URL filtering, whatever you have, and it's going to tell you the exact path that it takes, overlays, underlays, whatever it happens to be. On top of that, because you also have that same sort of common model, now you can also query it not just based on flows, but you can also query it based on configurations. If you want to do golden config checking, if you want to look at security group analysis, all sorts of things that get layered on top. And that's what's kind of changed over time. Like when I started, most of us were in the network troubleshooting sort of business, and it's really expanded a lot. And because a lot of people are trying to, figure out inventory, compliance, things like that. But when you have it all in one place, you can query it not based on here's all of these individual vendor characteristics, but just tell me, something simple across all of my clouds. It's very easy.
Yeah, I can definitely see, there's kind of probably I don't know if I'd call it a greater level of difficulty, but definitely within on-premises, this is obviously much more intricate, right? It's gonna pull control plane, it's gonna look at forwarding bases, things like that, and several different vendors in the mix. At least I would think with the move to cloud, a lot of this being API based, we've probably all heard the struggles of the major networking vendors supporting APIs and standard APIs and things like that over the course of time. But I'm curious, one thing that we talk about on the show a lot is the networking constructs that you're able to use, or really any constructs that you're able to use, are purely limited by what the CSP exposes to you, right?
Correct.
And because of that, 99% of the time, it's purely control plane. You're not looking at actual data plane stuff. Does that change what you do with the concept of a digital twin or this kind of predictiveness at all?
So when you start looking at data plane, those kind of things are really more of an enhancement on top of what you're looking at from the modeling standpoint. So once you figure out all of the possible flows, then you can figure out what the actual, load drops, things like that are on a per link basis. And what's handy about that is I'm not just saying, here's all of my 100,000 links in my environment, tell me what the load is. I can actually start to troubleshoot based on an application or a per flow basis. Like if I know, this one application is going to take these 15 hops in my network and it's going to traverse these links, I can see on a per app basis what's slowed down, what's being dropped, what's anything that would cause issues there. And you can also see it from an overlay underlay basis, because if you're just hitting tunnels on top of it, of course, if it's VXLAN or whatever, it's going to have a VTEP to VTEP. You need to be able to see that as well. So yeah, those things, that's a pretty well well-traversed, vendor space. So there's no really need to reinvent that, but overlaying that data on top of what's possible in the network winds up being very useful. Where the digital twin becomes more useful as well is when you're pre-provisioning things, or like you said before, that sort of post-mortem analysis where this is not my high transaction volume right now, but I need to be able to see what the path is before I do the application or afterwards to see what's going on.
Right.
That makes sense.
So I imagine what a lot of people are using this for is like, hey, I have an upcoming change, right? And I need to, move this VPC or, start advertising this route from on-prem or something like that. And they just want to see what's going to change, right? Is that, would you say, where your customers are extracting the biggest amount of value from the product?
Yeah, it's where you get a huge amount of value is doing that sort of pre and post change analysis. Because like I said before, those sort of flows that are important to my network, those sort of intent checks, I have those predefined in the network or just created on the fly. And whenever I do my change, whenever I close it out, I can verify here's all the checks that I have, here's all the configuration checks, here's all the intent-based flow checks. Are all those still functioning so that you can close out whatever change record you do in a more, in a more holistic way? And you have, we like to joke, we call it mean time to innocence, where it's basically the network is definitely not the problem because I can mathematically verify what the flows are inside my network. And that's not just on a manual basis. Like, we have hooks into like Ansible, I have a Terraform provider written that will let you do that on a pre-post change basis there, because we know most people in the cloud probably aren't doing, manual changes like we're still doing on-prem.
You'd be surprised. You'd be surprised.
More than you think. That is true.
You're not wrong. You're not wrong on that, but it's an ideal.
So tell us a little bit about the journey, if you will. Like, this is it's not new, right? But it's a new where it's not where Forward started. You brought in cloud. So how did you go from like, hey, we have no cloud whatsoever to, I'm kind of curious now how far I guess Forward has gotten in its cloud observability journey. Maybe that could be the last little bit that you tie up with.
So where it kind of came from is, when you're starting out in a particular piece of the network, when you start out with just modeling the data center or modeling a campus, the question always comes up where, okay, my applications span multiple places. So when are you going to be able to model, not just that part, more my SD-WAN provider or anything that's an overlay. So it was kind of an incremental journey to say, here's more and more things that we can model. Now we can do end-to-end everything in the data center. Okay, now we can do everything, add your wireless piece if you want to. We can add your SD-WAN to connect all of your sites. And as other SD-WAN providers got into sort of, hey, we can connect you to any one of your public clouds as well, it became very obvious, and people were like, well, yeah, we're doing everyone's somewhere in a cloud migration, either going or coming in some way or another. And, if they're doing multi-cloud, that's a whole other thing too. So it became very obvious that to really extract the best value and give people that full, you don't want to, when you're trying to do an end-to-end path modeling, having a hole in the middle winds up becoming a real, very sore spot for people. It's like, well, yeah, I can go up to this hole here, and then I'm kind of stuck there. To your point earlier, if you're using native AWS tools, you get to that hole, whether it's a third-party firewall or something, third-party overlay, where it's just, well, I can check to this point, but that's about it. So it became very obvious that that hole was something that needed to be filled. So, we started on AWS, added Azure, GCP. We're adding Oracle soon. So yeah, there's ways to add more and more things to that to get the most value out of it.
It's just a natural progression to start filling gaps, right? You want no holes.
Yep, exactly right. Yeah.
No holes in the network. Actually, so what did you? I'm curious about how. Like Cloud-WAN obviously came out, like 2.5 years now when it went GA. So what was because this is just fascinating to me in general. So like, how did it go from like, hey, here comes Cloud-WAN to, okay, Forward has to write, like, what did you actually have to do to start supporting Cloud-WAN? Like, what did you have to go figure out, like all the APIs basically? Like,
yeah. And that's really the tricky part. And that's really what kind of separates us from most. It's not, and same AWS or on-prem as well, is trusting what the documentation says is just a recipe for disaster. you have to packet test all of this. You have to check every feature that they have, and you have to packet test every bit of it, because you have to know exactly how it forwards. If I have a VGW connected to a TG, does it actually forward between each other when it's connected to a direct connect gateway? We've added things like things that customers have that even are hard for us to get access to, like AWS outposts and things like that. So yeah, it takes one. Yeah, the APIs fortunately are very public. AWS is really good about giving you APIs. Azure, slightly less so. Like they don't give you as good forwarding characteristics. Like if you want to figure out what's the routing table between any VNet, you have to have a VM attached to it, look at the effective routes, effective security groups. So it's a little bit more of a pain there. But yeah, it takes packet testing every bit of it to make sure that we know exactly how it's going to forward in all use cases.
Not to go down any specific rabbit hole, but how does it par with VMC, like all the VMware Cloud stuff?
Yeah, I mean, that's just NSXT. So NSXT is an overlay. We support that just the same. So yeah, whether that's on-prem or on the cloud, yeah, it's going to use all of the, if it's anything, on-prem ESX or whatever, that's going to use vCenter APIs. And then the NSXT manager, NSXT Edge, that's going to be just another overlay on top of it. So anytime you're doing anything there, it's going to have that. And yeah, when you have any other firewalls, we support gateway load balancer connections to those. So you can model that as well.
Nice. Cool.
Yeah, we'll have to see if we can get a demo at some point, because we've done demos before and put them on our YouTube channel and stuff. And yeah, I'm having trouble visualizing it, but I say that now, but you've actually shown me when we were at like RSA or one of the other shows, and it looked really cool. I think that's how we first started having the discussion about it. But
yeah, and that's what I've kind of when I talk to people about this, a lot of people are reminded with the old like packet tracer and things like that, where you could do some level. So the idea behind this isn't particularly new. It's like almost everyone says, "I wish I had this 10 years ago or 15 years ago." And yeah, there have been small lab versions of this sort of technology with emulation or whatever. It's the scale that really makes it different, and the support for pretty much everything out there that really changes the game that we've seen. Because yeah, I mean, being able to see your entire network offline and tell me what the path is of anything is hugely useful, because honestly, I mean, I spent much of my career doing exactly the same thing, and just, pings and trace routes, logging in this hop to this hop to this hop, figuring out where it is. And now, yeah, with the cloud, I can't really do that. Like I said, I can't go log into a transit gateway and look at the table. I mean, I can pull some APIs. Like just recently at Summit DC in the community day in the Bay Area, I did a session on VPC Reachability Analyzer 1, and it's fairly painful. It's got some pretty stark limitations on what it can do.
Yeah. When I was when we were writing the book that Chris and I were working on, the packed one, Reachability Analyzer was one of the ones I had to play with. It was my section of the book was observability, and so I got real used to understanding what the limitations are for AWS's limitations on observability. And yeah, I mean, Reachability Analyzer, it's one of those things where it works when it works.
Yeah.
You know what I mean?
Yeah, if you know the limitations, yeah, absolutely. Yeah.
Yeah, because they have Reachability Analyzer, then there's also Route Analyzer, and then I think
Route
there's
Analyzer, they have the Transit Gateway Network Manager, like they
TGNM,
have, they have several different analyzers, and they don't really work together. Yeah,
that's the thing. I think there's one for AWS Network Firewall too, so it's kind of like just all over the place.
There is now, but like you said, and I think it's one of those things where AWS is shipping its org chart in a way, because that's how you got ahead at AWS, was you come up with a new service like that, was so you'd have a bunch of people creating new services. And I feel like all of these observability services are just like little pet project type like things that became, and that's why they don't work together. Basically, you need something like Q or whatever they're saying, to stitch all that data together for you.
Yeah, not to get on a rant there, but yeah, every time I go to one of those sessions or one of those places at reInvent or something, it's like, I'm struggling to find networking content in any way. It's just like, give me one. It's like, I get it, this is a developer conference, but it's like, give me something here, guys. It's like I'm just trying to fill my schedule with any of the networking content. It's not so easy.
Yeah, couldn't agree more on that one for sure. That was rough.
Maybe because people do networking talks and they put them at the other end of the Vegas Strip in the top floor of the main.
That was rough. Finding my room was hard. I'll be completely honest. I've been to the Mandalay like 20 times when I worked at Cisco. Obviously, we used to have Impact or GSX there and everything. And it was this time going to find my room that I realized that it was a third floor to the convention center. Yeah. Because I've never gone up there in all the years that I've been there.
There was a third floor. This is the first time I've heard about it.
They have the little meeting rooms. It was a nice room. To be fair, it was a nice room, but it was hard. I'll be honest, it was hard to find, and I appreciate you coming out to support me for that. But yeah, I mean, of the 3 other networking talks that were there at reInvent,
That's it, yeah.
Right. It's funny. There's only so many, and then one of them's always a repeat of the last year's. Right?
Oh yeah.
So it's just like, so it's like, yeah, we're starving for new content out here.
Yeah, we're definitely bringing up the rear there, and and I think to your point is it's very much the way they're incentivized. There's always a new service that they're coming out with, and something that is not really, it's kind of orthogonal. They've got their minimum viable product out for everything else, so it's like, well, we'll bring something else, and it's like, okay, well, yeah, all right, yeah.
Yeah, I am curious to see how much more. Because every time I think that they've gotten to the point where, like, all right, you guys have probably exposed about as much as you can without impacting the hyperplane. Like, they managed to scrape a little bit closer to the skin. But, yeah, I'm curious to see how much further down the stack they can go to make available for people before they, impact themselves, basically.
Yeah, I've noticed they're trying to move a little more into observability. Like they put out kind of a flow, a flow checking system where it will kind of do, a service assurance sort of thing. So we'll see how much they go into with that. But I tend to agree they've only kind of uncovered as much as I think they're probably able to do at this point.
Right.
There's definitely a trust sort of it works mindset, which. And they definitely are pushing the more native services, which I totally get.
Yeah, of course.
Yeah, it's just, I tend to agree.
Greg, thanks again for coming on. I think this was a very cool conversation.
Absolutely.
We might have to pull you back in and do a demo because that was.
Yeah, I would love to see a demo.
Prepping for this, I actually did watch one of the Forward Networks on videos on YouTube about preparing for an audit, and you're kind of showing the visibility piece between AWS Transit Gateway and doing a firewall VPC, and then looking for VPC peerings. It was really cool stuff. So
it might have been me doing it. So yeah,
yeah, it was. I will say that whatever camera they were using when they were filming you guys talking, it was a very good quality camera.
Very nice,
it looked very nice. So
I give my regards to the videographer.
Yeah.
There you go. Where can people find you? Go ahead and plug anything you want. Plug your whatever. So
you can find me on most social medias. I'm at Captain Packet, so Blue Spy, X, LinkedIn, Xbox Live, PS Pro, so either one of those places. I'm pretty well. I'm on the Discord as well, the All About the Journey one, so I'm pretty active on there as well. So yeah, you can find me at most of those places. So but yeah, I'm always available there. So yeah.
Awesome. We'll have to put a link to your peer talk in there as well. Because I remember watching that one. That was good as well. So
yeah, that's true. At reInvent, I did a couple of peer talks, and that was a lot of fun.
That's right.
So, yeah.
Sweet. All right. Well, that'll do it for today. So thanks again for joining us for another edition of the Cables to Clouds podcast. I think this is coming out in the first week of January. So hopefully you had a great new year. And maybe by now you're starting to receive the book Tim and I wrote together.
Maybe we'll receive it at some point.
Yeah, maybe we'll get one. Who knows? But with that, we'll wrap it up. And thanks again. And we'll talk to you next week. Bye-bye. Hi, everyone. It's Chris. And this has been the Cables to Clouds podcast. Thanks for tuning in today. If you enjoyed our show, please subscribe to us in your favorite podcatcher, as well as subscribe and turn on notifications for our YouTube channel to be notified of all our new episodes. Follow us on socials at Cables to Clouds. You can also visit our website for all of the show notes at cablestoclouds.com. Thanks again for listening, and see you next time.